Okay, so we're going to work through actually building a Python package that we can install through pip. So when we're installing a package through pip, we're actually installing a package from this website here, the Python package index. So if we just search for something we all know, pandas, we'll see here that we actually have all of these different pandas projects. Now, the reason there's so many of these is because loads of people upload projects that say pandas in the name, as you can see. The one that we use and we know is this pandas 1.2.3. And we head on here and we can actually see all of the information about that package. Now, what we want to do is actually build our own package and upload it to this so that we can pip install it and build it in a way that other people can use it without any issues. So to start, I am going to use this package that I've put together quickly for this. And what it does is it simply generates a ASCII visual based on a few images that I've included in here. So these synthwave visuals. And all this package does is you initialize it and you press generate, and it will generate ASCII versions of these pictures at random. So it's pretty useless, but it's a good example. Now, the first thing we want to look at here is the directory structure. So we have this aesthetic ASCII directory, which is like our project directory. We can name this as we want. And then inside here, we actually have the package directory. So this is where we put all of our code. And in here, we have this init Python file. Now, this is very important. We need to have these files in order for our directories to be recognized as Python modules or Python packages. And then inside here, we also have this synthesize py file. And this is where all the code is going for me. And this creates a module within the package that we can import. Now you notice here my init file is empty, and this is something you'll see quite a lot. It's just there to tell our package builder which directories are parts of our Python package or Python subpackages. And then, of course, we have the README file here. So we can summarize this as this. We have on our top level, we have the project directory. And then we have the README file, and then we have our code directory. Inside there, we need to have the init file. And then in this example, we have two modules. We have module A, module B. Now, when it comes to actually importing one of these modules and using it in our code, what we would do is we'd write something like this. So we'd have from, and in this case, it's called code directory. Obviously, we wouldn't call our package code directory unless you really want to. And then we would import A for the A module or B for the B module. So in our case, this is going to be replaced with aesthetic ASCII, and this is going to be replaced with synthesize. And we'll come to actually testing that out later. But for now, let's just work through the other files that we need in our directory. I don't want to focus on the code so much here. So we have our README file and we have our code directory. The other files that we need are all configuration and setup files. And the most important of those for setting up our package configuration is the setup config file. So that looks like this. And if we go ahead and actually open this file, so we'll need to create it here. So setup.config, and there are a few parameters in here that we'll need to add. Now, for this project, we will be using these. So we have metadata, which is just the description or the data explaining what our package is actually doing. So this sort of thing will be displayed on the Python package index, and people will be able to see the name of it, the version, the author. They'll be able to get in touch with you through your email, and they'll also find a link to your website. So for me, obviously, I'm just using GitHub here. And all of those things are pretty self-explanatory, but there are a few that I think are a bit more abstract. So first, we have the long description. And you can write something here, but it's a long description, so I find it's better to include a file, and you include your README file. Okay, and then this will display on the front page of your Python package index site. And then we also need to explain that our long description is a markdown text file so that it is processed correctly. Next, we have our classifiers, and these are kind of like tags. So we're specifying the programming language that we're using. It's Python 3. We are outlining the license that we're using. And for that, we have this OC approved, and we're using an MIT license, which we'll cover pretty soon. And I want to specify the operating system. And for us, it's independent. You don't have to have a specific operating system to run this. So that's just the metadata behind our package. And then down here, we have some of the more important things for actually building the package. So here we're specifying the packages that will be included as dependencies. And we use this find here. And what this would do, it will go through our code here and find any package dependencies that we have. And this is provided by setup tools, which is what we're using, and I'll explain that in a moment. We also want to specify that we're using Python and we require either 3.7 or greater. And the reason that we need 3.7 or later is because we're using a package that came with Python 3.7 in order to include all of our resources over here. So that's our dependency on that version. And then here we're including package data, which again we are including because we have all these extra files that are not code files that we need to have included within our package. And that's why we've added that in there. So that's our setup config file. And alongside that, we also need a pyproject.toml file. And I mentioned before in the setup config that we're using setup tools. And in order to tell our package builder, which we'll use later, to use setup tools in the building process, we need to specify this pyproject.toml file. So we'll create that file here, pyproject.toml, and this is the code that we'll need for it. So we're saying here for the build system, it will require setup tools, which is the library we use to actually set up and process the setup.config file, and then Python wheel. And then here we're just specifying the build process that we'll be using from setup tools, which is build meta. Okay, and that's all we need, and that is just read by our builder, and it tells it how to build our package, which essentially tells it to use setup tools and process this and follow the instructions that this file is giving you. And next up is our license. Now, the license is quite important, and it's very important that we actually include a license file, because if we don't include a license file, we can get into a lot of issues in terms of people not knowing if they're actually allowed to use our code or not. And especially if you have people contributing to your project, if they contribute and you still don't have a license file, then it's quite odd because legally you're in a sort of gray zone as to whether you can actually use the package that you built. So a license is very important to include, but it's very, very easy to actually set that up. So all we need to actually do is we go on to this website called chooselicense.com, and we just select what we want for our license. So for me, I want it to be simple and permissive, so anyone can use it. And it gives you a license here to just copy and paste across. So I'm using the MIT license. Go back into project, and we just create a new file, and it's called license, like that. And we just copy that across, change this so it's 2021 James Briggs, and that's the license sorted. So it's pretty easy. Now this is all great and we have our code, but there is one modification to our code we need to make in order for this to work. So in our code at the moment, we rely on reading these images, which are in the same folder at the moment. Now, of course, we could have put these in a different folder. We probably would normally, but when we are building a package, we need any resources that we want to include in that package to be contained within a package directory, which includes a init py file. So that's why they're all included in here. Now we have a few images and we also have this font file, which is a true type font. And what we do down here usually is that we use the pill library and we just open the image like this. So we're selecting one at random. So it's one of these at random and we're just opening that. And it's pretty straightforward. Now, when we build a package, this won't work anymore because this is a relative path. So you will almost certainly get issues. So what we instead need to do is include these files within our package. So we've already done part of that. We've included them in this init file, but there is one more step. We need to include another file here, which is called manifest.in. And this manifest.in file needs to include any resources that are not code files that we would like to include within our package. So to do that, we need to write include, and then here we give the name of our Python package or subpackage. So it's aesthetic ASCII, and this is referring to this directory name here. And inside there, we want to include all. So this is wildcard for all files that end with PNG, which is our image files. Now you will notice that we also have some JPEG files as well. So we'll just copy that and we'll add JPEG as well. Now that's our image files, but we also have our true type font file. So we add that in as well. And that's our manifest file. Now back in the config, we know that we've included the manifest config file through this include package data at the bottom. So if this was false, this would not be read in and our extra resources would not be included. With it being true, it knows to expect a manifest file and then it reads this and includes these within our package. So that's great. And then in our code, we need to use a different approach to actually opening these images or other files. And to actually do that, we need two different libraries in this case. We need import lib, and from import lib, we need to import resources. And alongside import lib resources, we also need to import the IO library. So this import lib resources is specifically for reading in resources or files that we've included within a package. The IO library is for converting the bytes that we will read when we import the resources into readable file-like objects. Because the code that we use down here reads our images and font from file. So this allows us to pretend that the bytes that we've read into our Python code is actually a file rather than a set of bytes. So with that, this code here, this line, instead becomes this, which is a little more complicated, but this is just what we have to use. So here we're using the resources that we imported and we're using open binary. It's in the aesthetic ASCII package. So we need to include that. That is the directory name here. And then this time we're using the same thing again. We're just using the image and we're selecting one at random. And then we're just importing or reading that like we would any other file. And then when we use this, we would expect a file path to be passed to this function. So we imitate a file path by using this IO bytes IO function and passing the image binary to that. Now that's our images, that's sorted. And then we also have our font down here as well. Okay, so at the moment what we have our font path, and this is just reading from file. So we've got this image font, true type, and then we're reading it in there. Now we're going to be using the same thing again. We're going to be using the open binary function. So we do with resources, open binary. Again, we include our aesthetic ASCII package name, and we also include the font path, which we've just defined there. And we again read that in just like we did before. So we'll call it font. We do fp.read, And then we need to initialize that font. And what we were doing here was reading from path before. So again, we need to use the IO library to imitate that. So we do IO bytes, IO, and font. And with that, all of that will now work. So that's everything set up. And what we do once we have it all set up is we first test that it works locally. So the first thing we need to do is navigate to that directory. So for me, it's in documents, projects, test, aesthetic ASCII. And once we're in there, we can just do pip install dot. And this will do a local pip install from the current directory. Okay, so you can see that that worked. That's great. And then here you'll probably want to just test your new imported package. So for example, for me, I would go from aesthetic ASCII, import synthesize. And then I would go through the code for actually testing it. I'm not going to do it here. But as long as that all works well, then we should be good to go. So at this point, we do Python module build. And this package, this module will actually build our package. And what you will find in the directory here is that we'll get a new directory called dist, which means distribution. And this will contain 2 files. So we can have a look. At the moment, we have the tar file. And now we have the wheel file as well. Now these are 2 files that are going to be uploaded to the Python packaging index, and they are our package. So after we've done that, we need to upload our code. The first thing we do before we upload it straight to the Python packaging index is we upload it to the test version of the Python packaging index, just to make sure that everything is working. And we find that over at test.pypi.org. And of course, you will need to register here. So you go through register, enter everything you need. You will need your username and password when you're running through the upload process in your prompt window. So make sure you have that set up. And we'll also need to pip install Twine, which is a package that will allow us to upload everything to Python packaging index. Now I already have it installed, so I won't go ahead and do that. Instead, what I'll do is Python module Twine, upload, repository, test, Python packaging index. And here we need to pass everything within our distribution folder. And we run that, and everything will be uploaded to our Python packaging index. Once we've done that, we want to actually install our package, but from the test Python packaging index. So to do that, first, because we already installed our package, we actually want to uninstall it. And we just uninstall that, and then we can install it again, but through the test package index. So to do that, we just pip install, and then we set the install index to the test Python package index. So we just do test pypi.org. So that's simple. And then we specify our actual package name, which is aesthetic ASCII. And we should find that that will actually run and install. And then at this point, this is where we want to test it again. Now, if you are using resources and everything with your package, that is something to definitely check that everything is being read correctly and it's just functioning. Now, once you're happy that everything is working correctly, this is where we finally upload it to the actual Python packaging index. Now, this is the same process again. So we do Python module, using Twine, we're using upload, and we also type repository. Now this time, instead of writing test PyPI, we write PyPI. And again, we use our distribution. We execute that, it'll ask you to log in, and then we're done. And we'll be able to see our Python package over here. So we'll be able to search for it, or you can just come over here to, if you've logged in, click on your projects, and you'll find here we have our actual package. Now I can view that and it will come up with the README file. On the side here, we have all of our metadata. So we have the MIT license, the author, and that includes an email link there as well, which Python version it requires, the language, and so on. We can also click on the home page, which will take us through to the GitHub repository. So that's all set up as we would want it to, which is pretty cool. And most importantly, we can actually just pip install it and start using it. So first I'll just pip uninstall. And now all we need to do is pip install our package. And it's that easy. So that's everything that you need to know for actually building your own Python package. It's a really cool thing to be able to do. And I would definitely recommend learning how to do this and building your own packages. So thank you very much for watching, and I will see you again in the next one.